Okay, so for our seventh problem here, we have another tangent secant. Okay, tangent secant power theorem problem. So Roshane is inventing a roving trash bin in the city streets of Metro Manila to reduce pollution in the dwelling areas. She's planning to name her invention Recycle. Its hook, as outlined by the triangle MAK on the image on the right, is responsible for catching any identified plastic products or waste materials on street. So for her project to be constructed, she needs to find the value of segment MA, okay, so this one, and given that EA is a secant line and AK is a tangent line in decimeters, can we help Roshane out? Can we find the measurements of MA and AE for this problem? Okay, so what are the measurements of this given line segment and the secant? Okay, so to do that, we can use the tangent secant power theorem formula. Again, we can write the formula here. Okay, so we can remember it much more clear. So in a clearer way, so tangent squared is equal to the outer segment multiplied by the sum of the inner segment and the outer segment. Okay, so therefore we have here our tangent. The tangent is equal to 14. That's AK, right? AK squared is equal to, okay, the outer MA multiplied by the inner MA plus the outer ME. So this is going to be equal to 14 squared is equal to MA, which is Q plus 9 multiplied by the quantity M plus A, so that's Q plus 9 again, plus ME, which is equal to 16. Okay, so 14 squared, that is simply equal to, okay, 196. Okay, 196 is equal to Q plus 9, okay, Q plus 9 multiplied by Q plus 9 plus 16, so that's going to be Q plus 25. Okay, so this is going to give us 196 is equal to Q squared, okay, and then 9Q plus 25Q, so 25 plus 9, that's going to give us 34Q. 34Q, and then 9 times 25, so that's going to give us 225. Okay, and from here we can use the transitive property or the inverse addition property of equality. We can transfer 196 to the other side, so therefore 0 is equal to Q squared plus 34Q, and then plus 225 minus 196. And 225 minus 196, that's going to give us 29. Okay, so this is going to be plus 29. Okay, and again we can use our calculator to find the value of Q. Okay, so for this one, our A is going to be equal to 1, our B is equal to 34, and our C is equal to 29. Okay, so let's try to use our calculator here. Okay, so we have A is equal to 1, B is equal to 34, and C is equal to 29. Okay, so for our first value, we have here x sub 1. Okay, x sub 1 is equal to negative 0.9. Okay, so this is going to be Q sub 1 is equal to negative 0.88. Okay, and the second value for Q, okay, so that's Q sub 2, so that's going to be equal to, okay, negative 33.12. Okay, so for this one, guys, we cannot take the value of negative 33, okay, because that will give us a negative value for AM. But we can take the value of Q sub 1, negative 0.88, even if it's a negative value, because if we add Q and then 9, we'll still get a positive value for AM. So therefore, AM is going to be equal to Q plus 9, and Q is equal to negative 0.88 plus 9. Okay, so 9. Okay, so 9 minus 0.88, so that's going to give us 8.12. Okay, so therefore AM is equal to 8.12 meters. Okay, so there you go. So AM is equal to, or MA is equal to 8.12 meters, and AE, okay, AE is going to be equal to 8.12 plus 16, okay, because we have your ME is equal to 16. So 8.12 plus 16, that's going to give us 24.12 meters. So these are our answers for this given problem right here. Okay, so let's move on to our last problem here. Berlin wants to create an innovative air conditioner in the shape of a triangle. Given that her free cooler's top view is shown on the image on the right, find the perimeter of triangle FOS. Okay, so for this one, guys, we're going to use another theorem for the tangents of a circle. Okay, so so let's try to go back. Okay, if we go back, you can see that the tangents, okay, tangents of a circle from an external point, okay, from an external point, okay, of a circle are congruent. Okay, so that means if we have here an, okay, congruent. So if we have here an external point, let's say we have here point F, it's an external point of circle W. So therefore, FE and FL are congruent to each other. And we can also say that since we have this point here, it's an external point, and E and R are tangent to the circle, same with E and L. So therefore, 16, if this is 16, then this is also 16. And since we have here two tangent lines again, LO and RO, so therefore, if this is 35, this is also 35. And from here, we can get the value of the perimeter of triangle FOS. So the perimeter of triangle FOS, okay, is going to be equal to FL plus LO plus RO plus SR plus ES plus FE. Okay, so we have your FL is 20, LO is 35, RO is 35, SR is 16, ES is 16, and FE is equal to 20. Okay, so we can add that. 40 plus 70 plus 32. Okay, because 16 plus 16 is 32, so it's going to give us 142 centimeters. Okay, so therefore, that's the perimeter of Berlin's air cooler. Okay, from the top view, okay, of the triangular air cooler of Berlin. It's equal to 142 centimeters. And that's it for chords and tangents for lesson 3 of the 4th quarter.